There's a kind of digital crystal ball that engineers use to shape pretty much everything in our world, from the phone in your pocket to the massive skyscrapers that touch the clouds. It's called finite element analysis, and it's this amazing technology that can literally see the future and predict failure before it ever has a chance to happen.
So, let me ask you a question. How do you test a skyscraper to see if it can survive an earthquake before you've even started building it? I mean, how do you know a bridge is going to hold up under the weight of thousands of cars every day? You can't just build it and cross your fingers, right? You need a way to see all those invisible forces at work.
And that's exactly what finite element analysis, or FEA for short, is all about. Okay, so think of it like this. Imagine you could take a really complex object, like an entire airplane wing, and digitally break it down into millions of tiny, simple building blocks. FEA then runs incredibly complex calculations on every single one of those tiny blocks, simulating real-world forces like stress, heat, and vibration. Then it puts all that data back together to give you a complete picture of how the entire wing is going to behave. It's pretty much an engineering superpower.
So, here's what we're going to dive into. We'll start with this idea of the digital crystal ball. Then we'll look at how it's used in some massive engineering projects. After that, we'll shrink things down to the cars and materials we use every day. We're also going to see how it's changing things for our health and for the planet. And finally, we'll uncover what we're calling FEA's invisible revolution.
All right, so let's dig into that core idea. FEA as the science of prediction.
What's so incredible about this is that FEA basically lets engineers live in the future. They can see exactly where a tiny, microscopic crack might form, or where a beam might start to buckle, or where a part could overheat, all inside a computer. And that means they can fix these massive problems before they even exist, which saves a ton of money and materials, sure, but more importantly, it saves lives.
And nowhere is that predictive power more critical than when you're dealing with absolutely massive structures. So let's take a look at civil and aerospace engineering.
The scale here is it's mind-boggling. We're talking about using FEA to simulate how a skyscraper will sway in gale force winds, making sure it's not just safe, but actually comfortable for the people inside. Or analyzing the crushing stress on a huge steel bridge with thousands of tons of traffic pounding on it day in and day out. And in aerospace, it's even more critical. FEA can pinpoint how tiny, invisible cracks could grow over time in an aircraft part, which guarantees safety over millions of miles of flying.
But it's not just about these giant structures. FEA has totally changed the game for how we design and build the stuff we use every single day.
And this right here, this really shows you the revolution. See, before FEA, if you were designing, say, a new car part, you had to physically build prototypes, crash them, see what broke, and then just start all over again. It was so slow, incredibly expensive, and super wasteful. But now, with FEA, engineers can run thousands of virtual crash tests in a single afternoon, tweaking the design to make it stronger while using the least amount of material possible.
This means they can perfect something like a simple parking brake lever through a process called topology optimization. It's wild. That's basically where the computer figures out the absolute perfect shape for a part, carving away any material that isn't totally necessary. You end up with these crazy-looking, organic shapes that are super light but incredibly strong. And this thinking goes all the way down to the factory floor, too. FEA can simulate the intense forces needed to cut super hard steels, which helps make better, more efficient tools.
But the impact of FEA goes even deeper, into two of the most important fields out there today: our own health and the health of our planet.
Okay, this is where it gets really personal and just amazing. Doctors can now take a patient's CT scan, create a perfect digital twin of their hip joint, and then use FEA to simulate exactly how all the forces move through that joint when they walk or run. This lets them design a custom hip implant that is a one-of-a-kind perfect fit for that single person's body. I mean, think about how that can change someone's life.
And that same idea applies all over the place. From creating 3D models of your teeth to design a better dental crown, to optimizing giant wind turbines so they can handle constant vibrations and produce clean energy for decades. FEA is even used to check the structural safety of waste incinerators, making them safer and more efficient. It's everywhere.
So, when you put it all together, you start to see this quiet but truly profound revolution that has completely reshaped our world, mostly without us ever noticing.
So here's the bottom line. FEA is kind of the unseen hero of our modern world. It makes everything safer by predicting failures in bridges, planes, you name it. It makes innovation faster, cutting down design time from years to months or even weeks.
It makes our designs smarter, letting us create things that are both lightweight and unbelievably strong. And it actually makes our world greener by cutting down on wasted material and making everything from cars to power plants way more efficient.
It's this incredible invisible force behind so much of our modern lives, which really just leaves us with one last very exciting question to think about. Now that we have this powerful digital crystal ball, now that we can test the very limits of what's possible, what impossible things are we going to build next?